clicking.
Hello, Pete. Welcome to the Sleepy Time episode of Stay Positive podcast. Ladies and gentlemen, boys and girls, and everyone and everything in between. It's good to be back. How are you all doing?
Another day. Yeah, as if they could answer. Another day, another dollar. That's what we say. I've had a long week. I'm just bad. I'm just glad to be back.
Yeah. Every end of the month is always really busy at my company, so I think I had a busy week too. Both of us just going through the grind.
The grinder. Yeah, it's starting to get busy. But who cares? Because we're staying positive and we...
So Pete, I have a question for you.
Question
or
me.
rather just a thought, because I was just through all this hard work, I've been thinking about life and stuff. Our go-to topics at the Stay Positive podcast.
Aye.
All right. So the Big Bang, that's like an explosion, right? That's like that's the one of the theories on how the universe started is just some big explosion out of nowhere.
Yeah, basically.
So I've been thinking, what if that explosion didn't come from nowhere? What if someone or something like made that explosion? Like what if humanity existed before, or something like its equivalent existed before and just created a giant explosion that created the universe? What if they're doing it right now? What if they're creating multiple universes? Maybe what if that's the multiverse? What if it's just some guy just like dropping bombs everywhere and it's just big explosions? What if? What if? I'm just saying, like
Aye.
It's a big explosion, and it's
well.
Because you're talking about like the heat. Because I remember you mentioned like the heat death of the universe. I don't remember if we talked about it on the podcast or if you were just trying to lower my faith in life more off camera. But it made me wonder. It's like if that's true and the universe like loses all its heat because it didn't pay the electricity bill and it just couldn't afford to like keep the heater running, what could like we make our own explosion? Can we bring the heat ourselves? Because theoretically, everything that exists came from somewhere.
That's true. So the way that the Big Bang works is basically what you said. But we don't really know exactly what happened at the instant it happened. We know to 10 to the minus, I don't know, a lot of big number, 10 to the minus something seconds, but it's not zero, right? If we knew what happened at the 0th second, then it would be a lot easier. But
how do they know? Like, where did they come to that conclusion that everything started with a bang? That big bang?
Well, because so I could give you some history lesson right now. You know who Edwin Hubble is?
No.
Or who he was? You've never heard of Edwin Hubble?
No.
The dude that telescope is named after?
Humble Bundle? What?
Hubble, bro. The Hubble Space Telescope. Have you never heard of that?
No.
Okay, welcome to reality, Alex. Anyways, so there's this. He was famous. I forget what he was like. His astronomer or astrophysicist. I don't know. I forget the name of his job title.
Scientist. He was a scientist.
Sure. So basically, he found that after observing the sky and stuff, he found that all the things were moving apart from each other. And so he was like, what is going on here? Why is everything moving apart? And he used the Doppler effect to measure that. You know what the Doppler effect is?
No, I've heard of it. Tell me. Give me brief lesson.
So the Doppler effect is, or imagine a train. Quick side note. Imagine a train coming towards you.
Right.
And the frequency is kind of shifted in a way to be higher as the noise approaches your position. And then as it leaves your position, the noise has What's it
Yeah,
called?
it's
Or
the
is it
sound
wavelength?
waves are longer. The wavelengths are longer.
Oh yeah, it's the
apart.
wavelength. What am I saying? Not frequency.
Pete. You're
Okay,
the
you get it.
scientist. Yeah,
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 yeah.
I got it. It's basically that idea that when a train or a car is like coming at you, the sound is getting like of a higher pitch or a higher noise,
Yes.
and when it's going away, it sounds like deeper.
Yes.
Or okay, so he
So
was
this
using sound.
applies, yes. So I mean, we use that for sound, but it applies to light as well. So Hubble found that things in the universe were moving away from each other, and he was able to observe that by seeing how the light coming from different objects, interstellar objects, was redshifted, which
Is
shows
the
that they
longest
have,
wavelength.
yeah, a longer wavelength. And that means that what I just said. So he's like, whoa, what's going on over here? And then one thing led to another, and people were like, oh, yeah, so we started from a singularity, an infinitesimally small point where things exploded into what we have today.
So
But
where
it
is
took
the
a
center
long
of the
time.
universe?
No, that's a great question.
Because
I
if
mean,
that's true, if everything's moving away, there has to be one center point where everything's moving away, right? Is that real, or is everything just moving away in
I mean,
general? No, there has to be a
mathematically,
center.
no,
There
no, no,
has
no.
to be.
Mathematically, it makes sense. Whether or not that's actually true, I can't tell you. But it
Mhm.
makes total sense. Because, yeah, or rather, what I wonder is what would you find in that center if you found it?
I don't know. What if God was there?
Dude, shut up.
No, like seriously, we don't know what's there. We don't know what made it even.
Or we don't know if it exists, to be fair.
That's true. And there might not be a center. Maybe there's a fourth dimensional center, where the center is like on another plane of existence that we can't even fathom.
I
Who
mean, I
knows?
like to imagine that there are higher dimensional realities that we're unable to comprehend because we're three-dimensional beings, but it'd be pretty cool if we got to the point that we could, get out of that. Because realistically, it took us, I mean, to be fair, tiny microbial organisms, they live in 3D technically, but they're so unbelievably small that you could practically consider them almost 2D.
I mean, from the way you're describing it, they might as well be 1D, one dimensional.
No. I'm saying that they're so small, but we live on a way larger scale.
Just because
So
something's small doesn't mean it's not three-dimensional anymore.
true, but also I'm not sure that they can comprehend 3 dimensions as we can. Like, if you put the Empire State Building in front of a little bacterium, do you think that it would know what it's looking at or what's right next to it? Probably not.
Yeah, it probably is not looking at anything because it doesn't have eyes because it's stupid.
Oh, okay. All right. So anyways, you asked if we can make an explosion that could do that whole thing.
Yeah, just restart the Big Bang.
Okay,
Make our own
so
synthetic Big Bang.
so technically, yes. Because what happened was the Big Bang was basically an explosion of all the contents of the universe just in a very small point. Super dense. Imagine a black hole times a trillion. That's how dense this thing was, which is weird because black holes are the most dense things ever. So this thing explodes and we have just a catastrophic array of particles shooting throughout everywhere, and things are super hot and things are flying all over the place, and one thing leads to another, and a few billion years pass by and we find ourselves here.
Maybe that's what it is. Maybe it's just a bunch of black holes, and because they say when something's in a black hole, it never leaves. It's stuck forever. Or nothing can escape, not even light can escape a black hole, is what
Yeah,
it's...
that's true.
So hear me out. Shut up, Pete. Hear me out. Hear me out, Pete. What if all this moving away from each other stuff is actually things moving toward black holes, and as time goes on and enough energy is absorbed into those black holes, that's what the Big Bang is just a black hole that ate too much and just explodes.
I mean, I actually have thought about this idea a lot, to be fair. I like it too because it's so absurd but makes a little bit of sense. Have you ever heard of the idea of a white hole?
You've explained it to me, but explain it to our audience.
Okay, so basically a white hole is the opposite of a black hole. Instead of having an ever-present attractive force for everything, it has a repulsive force. So let's say you were going to fall within the event horizon, which is quote unquote the point of no return when it comes to a black hole. You can't escape. You can't get away. Now, if you were near a white hole, the exact opposite would happen. You would physically be unable to go to the center. That thing would be pushing things out. And so some theoretical physicists are like, what if the Big Bang was just a white hole?
I mean, where is it then?
Well, that's the thing. We don't know. So imagine if the center of the universe is a white hole. And what if every black hole... Here's an even crazier thought. What if every black hole has a white hole counterpart? Which would mean that there are insane amounts of universes because there are millions and billions of black holes out there. So that means that we live in a multiverse, but it's not like we could ever see it. It's like a foolproof system for us to never be able to interact with our or with other systems. We'll call a universe a system, you know? So it's like perfectly controlled. We're perfectly controlled within our system. And that way, you know, it's freaky. Because the people that made our simulation, they thought about these things.
Space is weird, man.
Dude, space is weird. I love it. It's crazy.
When you even when I'm imagining space, I'm usually imagining like a 2-dimensional map, but like space is 3-dimensional. There's no left and right. It's just everywhere, anywhere. Just go pick a direction and you'll find something. You'll find another Earth if you go far enough.
Dude, I know. And it's the craziest part about it is that everything that you can imagine with objects on Earth in general, that stuff exists just on such a massive, massive scale. Like, I'm not saying that I could go find a pair of headphones lurking in and out of our solar system, but, you know...
But you might.
I know, but, like, something like Earth compared to our galaxy, for instance, would be like me looking at a crushed grain of sand. Like, we're so freaking small, bro. Yeah, we're so small and insignificant. It's crazy. That's why I tell people to stay a little humble, because in the grand scheme of things, you never know if you actually matter or not.
Speaking of like size in the universe, you know, like atoms, right? Is it possible for like you to destroy an atom and like recreate it somewhere else? Like, wouldn't that be teleportation to, like, you know,
destroy an atom and
like
recreate it in another location in space?
To like basically to move an atom from one spot to the other, but not like linearly, but through teleportation, to like move from one to the other like that. Yeah, it's hard to explain because teleportation doesn't exist yet. You know, like the Beam Me Up Scotty in the Star Trek?
I actually never watched Star Trek, so to be fair, I don't.
No, but you know, like, that expression, and you know...
Yes, I do. I've heard of it.
So it's basically, if my memory is correct, it's just like they convert their bodies into light, and then the light just gets transferred to wherever they want, and boom, teleport. So...
I mean... So I know that, like, what you're saying is like 50% right and 50% wrong. The way that teleportation would work, have you ever heard of quantum entanglement?
No, Pete, enlighten me.
So basically what it means is a particle, a subatomic particle, electrons usually, and whatnot, they would become entangled if and this can happen theoretically at any distance, large and very small. They become entangled when they have the same orientation about themselves. So in other words, an electron's spin is one way to measure its orientation. And there are a lot of other things, but I'm just kind of breaking it down really simplistically for you right now. So anyways, the way that this works is, let's say I have one electron in one point in space-time, right? And it has a spin of certain, like we'll say it's spinning in the up direction, whatever. Then I have another electron in France, right? And that if that thing's entangled with the electron that's right here next to me, then that thing is literally spinning the exact same way as my electron, right?
Okay.
And so theoretically, using that idea, if you can kind of recreate that with all of the atoms and all of the particles in your body, that would mean that you'd be able to essentially teleport someone from point A to point B.
So if two electrons have the same spin, they can move between each other?
Yeah, well, it's not only spin. There's a lot of stuff. Like I said, I only took one aspect of it. Like I said, very simplistic definition. But the whole key here is quantum entanglement.
So basically, in some space, anywhere, I have all the atoms in my body have to match all the atoms in another space in the exact same shape that I am, and then theoretically I can jump between the two.
Wait, say that again?
If my atoms of my body are matched with another group of atoms that are the exact same shape and exact same characteristics of spin and whatnot in another plane in space, then I can move between the two spaces within where I am and where I could be.
Essentially. But it sounds more like cloning than it does teleporting, but in reality it is teleporting. Because there's this also should not be confused with this thing called quantum tunneling, which technically is also applicable.
Teleportation?
Huh?
Is it also teleportation?
Well, it's weird because the answer is yes and no to that as well.
This is, judging from the name quantum tunneling, it sounds more like you're just moving your atoms very quickly from one place to the other. You're not really transporting them like instantly. Is that right?
Yes. I mean, well, yes and no. Dude, can I just precede this by giving a quote from Richard Feynman and saying, if you think you understand quantum mechanics, then you don't understand quantum mechanics. And this guy was one of the smartest human beings to ever live on this planet. He was a professor at MIT. He worked on the atomic bombs, and he was literally I don't know if he was a Nobel laureate, but this guy was smart.
He was a genius.
He was smart. And even he struggled with this stuff. So don't take this from me like I'm some kind of guru on quantum science. But anyways, so what it is
I
also...
should just quit everything I'm doing and just study this because it's so fascinating.
It is pretty fascinating.
It's basically mastering
out of
space.
our intellectual reach sometimes.
Yeah, but it's basically like mastering time and space.
I mean,
sounds cool. Until you actually read the books, in which case it's boring and hard.
No, it is difficult. So anyways, a quick description of quantum tunneling is, let's say there is, do you know what electric potential is?
Yes. No.
Think of voltage. You know, voltage.
Okay, a current, yeah. An electric.
No. Current and voltage are very different.
Voltage is the valuing of electricity, no?
No. Voltage is the difference in potential between two points.
Oh, okay.
Okay, so anyways, let's imagine a potential barrier. So, right, like I have a point A, point B. There's a voltage between point A and point B, or potential difference, which equals voltage, right? Point A, point B. So let's imagine those 2 points make a barrier. It's called a potential barrier, right?
Right.
What quantum tunneling does is it basically allows a wave function or a particle, because light can be both a wave and particle. Once again, quantum mechanics is weird, man. It allows this thing to propagate through that potential barrier and essentially it's not moving through it, but rather it starts at one point and then just ends up at the next point type stuff. And if that makes any sense at all. So it like imagine there's like a super shifty just imaginary tunnel there, and it allowed it to tunnel between the one side to the other side in an instant. And
what's the barrier supposed to be?
It's just a potential barrier.
What if there is no barrier? Then quantum is this just basically quantum entanglement but with a barrier in between?
No. This is totally different.
What if there's no barrier? Then you don't need a tunnel. You just walk from point A to point B.
Well, sometimes you can't because there are other things prohibiting. Like, for instance, light bounces off walls, right? It can't just travel through a wall.
Maybe if it has a power drill, it could.
Okay. I mean, if you want to just think of it super simplistically, then yeah, totally. But no. So the barrier is there to no. It basically means that this phenomenon occurs basically for particles, waveforms that move from one place to another with something blocking their movement, and they're able to move through that barrier even though they're not supposed to. So they literally just appeared from point A to point B.
Is this real, or this is
completely...
Is real. So like you could theoretically do it.
What?
So you could theoretically do this. This is a thing that we could.
No. This isn't theoretical. This is real.
So why aren't we doing it?
Well, because I'm not a beam of light, man. I can't do it.
So only light can do this attribute, go through quantum tunneling.
Wave functions, yeah.
So I can't unless I convert myself to light.
Yeah.
Is that possible? Can we convert our own atoms to light particles?
No.
Why not?
Well, because it's like asking to turn me into a block of iron, man. How's that gonna happen?
Eat more.
No, man.
I don't know. What's the food that has spinach? Eat more spinach. That has iron in it.
I have my own chemical composition, and that's what makes me up. There's no way I can possibly rearrange my atoms to make myself into a block of iron.
Does light have any chemicals in it?
No.
Or light is just light? It's
well,
itself.
light is
electrons.
No.
Oh, what's light?
Yeah, so this is actually something I really messed up when I was learning kind of modern particle physics, like the dumbest version of this, because this stuff is complicated. So basically, obviously, it makes sense that light and electrons are totally different, but they kind of operate really similarly. But
so what's light?
So photons. Have you heard of the word photon? Yeah.
I have heard of photons.
That's a type of particle. It's a type of, it's not a subatomic particle, or I guess it is. But that's not important, what I'm saying about that. The point is it is its own thing, and it doesn't make up any of our matter because light doesn't have any mass.
It doesn't, or it's extraordinarily small? Because like if light doesn't have mass, but it has a particle, it's like saying it exists, but not really.
Mm-hmm. Yeah, light doesn't have mass. That's just a rule of thumb, dude. But you want to know, here's what messes with scientists a lot, and I mean, it makes no sense to me either, and basically every person that studies this stuff, is that Einstein has this super famous equation, E equals mc squared, right?
Yeah.
That means that energy equals mass times the speed of light squared. And so if we just take away this arbitrary constant, because you know how math works, this constant meaning c, the speed of light,
yeah,
then we have a proportional relationship between energy and mass.
And light has energy.
Yes, light indeed does have energy because it travels with energy, and he showed that was possible.
How did he come up with this formula?
Well, so have you ever heard of the photoelectric effect?
No, Pete, I have not heard of the photoelectric effect.
You don't have to sound so enthusiastic.
I am enthusiastic. Shut up, Pete.
So basically, what this thing is Einstein. Oh, also Einstein got a Nobel Prize for this. Basically, he bombarded a. I don't know if it was a piece of metal. It was something. He bombarded a material with light.
I think it was
And
gold. Wasn't this that thing where they shot light particles at gold and it saw that sometimes it goes through and sometimes it doesn't? Which
no, that was Rutherford's gold foil experiment. You're
oh,
thinking different stuff.
okay. What
But
was he shooting?
he shot light. He shot photons at a material and measured that electrons came off the material. So you know how collisions work, right? If you hit something, then the thing that's being hit by the other moving thing is going to move out of its place, right?
So that means light had something because it had to knock it
Yes,
out.
exactly. The light that hit the material knocked the electrons away, which means that the light had energy,
And
but light
mass.
has no mass.
How does that work?
It doesn't work, but it does. That's the point.
These photons, can we, like, they're a thing? Like, they exist? Like, because, like, atoms, we know about atoms because relatively they can stand still. Photons, do they ever stand still or no? They're always moving
Photons?
because they're light or light.
I mean, I implore you to find a beam of light that's not moving.
That's my point. Is like, is there a way to capture light, like freeze it in a way? Like freeze is the wrong word, but you know, like to stop light in its tracks.
That's a marvelous question that I could not possibly answer for you. I don't think that's possible, quite
Because they're
frankly.
like, the reason I ask is there's this like funny paradox where it's like theoretically speaking, we are always standing still. And
Huh?
the paradox is basically if you took a picture of an arrow, right? If you shot an arrow and you took a picture of it, in that moment in time, it's stuck in place forever. Like in that moment in time, it's there, and it'll always be there for that moment in time. And if you take a second picture, that arrow will also still be there, motionless forever, and it never can move because you took a picture. And the paradox is if you took like infinite pictures, you're infinitely standing still.
But you're not.
Exactly. That's why it's a paradox.
But is that really a paradox? Because in the picture, you're standing still. All right, wait. We'll talk about this after, but I
Okay.
want to
Okay.
first answer your question because I found something pretty interesting. So technically, I'm wrong.
Well, you can
And
freeze light.
we can indeed stop light. Or I don't know if this article is BS. It's also from like 2013, but it's
When the world
apparently
was
some scientists found that they can trap light inside a crystal by using this technique, quote unquote, called electromagnetically induced transparency. Basically, they have a cryogenically cooled crystal. This is opaque crystal as well, so it's really cold because you know when things are really cold, it's really hard to move for particles. So it makes sense. They want to keep it super cold, and they fired a laser into the crystal, and the light was just trapped inside, and it was actually brought to a standstill. They kept it there for like a minute.
oh cool.
Apparently, that's weird. Yeah, the light was not bouncing around. In essence, it stopped, but it was
So
still there.
in a way, that's still kind of hard. You can't really
This
study
seems
it.
like such science fiction to me, though. I don't even know if that makes sense.
Well, let's assume it does. It's real. This is real and not science fiction. If they did do that, it's still kind of it's cool. It's amazing, but
Yeah,
like, how do you study it if it has to be stuck in that crystal? You can't really do anything. Now it's just stuck there.
yeah. Here's the other thing. I don't know if it's a minute, but I feel as though something like that would be so short in time. That phenomena in general, like it would last. I don't think it would last a minute, bro. It would probably last on the order of milliseconds, maybe even smaller than that. You know, like for you know CERN, right? The
Who?
big Large Hadron Collider.
Yeah.
Yeah, so you know how they can actually create miniature black holes, right?
But
Just
they're
by
not
colliding
real.
particles. No, they're real.
They're bottomless. They don't.
They are very much black holes.
Oh, okay. So we can make those ourselves?
Yeah. But you can thank your boy Stephen Hawking for helping us out on this one. So basically, they make black holes, but so unbelievably small that as soon as they're made, they just radiate away. Because Hawking showed through this idea of Hawking radiation that black holes also deteriorate over time.
But
because
don't they
radiate
also
away some of their mass.
But they
by
also get
radiation.
bigger over time.
Yeah, they get bigger if they suck things in. But if there's nothing around to suck in, and that's basically what happens in a closed system like the Large Hadron Collider, there's nothing in there. Like they collide particles in as close to a vacuum as possible, or I'm pretty sure it's a vacuum, or like as close as possible.
Yeah.
And there's nothing else. So what could that thing possibly take in? It's so unbelievably small that all the other stuff it can't possibly rip the atoms off their current bonds.
So it's not strong enough to eat, essentially.
Because it's so small, and it basically exists for a tiny fraction of a second, only because it radiates away instantly.
Also, we probably don't want a black hole created on Earth.
Really wouldn't. I don't know, because
What if a black hole was a portal to a new world? What if we could create what if that's the secret to like finding
Alex, I'm so glad you asked that, because that's literally what we were talking about before.
With the white hole, I know.
Yes, exactly. Dude, I've been thinking about something like that for the longest time, and I feel like a lot of theoretical physicists think about that, and it's just such science fiction garbage, but it sounds so cool.
I know,
and
but
that's why I said like multi-dimensional existence right there. But like I said, our simulators, they they were smart about it. They knew, because basically what happens if, let's say, you try to get close to a black hole,
you die in 0.1 of a second.
Yeah, because there's this thing called spaghettification.
Spaghettification.
I apologize to our listeners for this gruesome. Not technically gruesome.
You turn into spaghetti. I got it. All
right.
Right.
Your body just gets stretched and all your atoms get ripped apart.
What is this, Mike TV from Willy Wonka's Chocolate Factory?
So, anyways, you get to the event horizon and you get spaghettified, and say goodnight. So you can't really make it to the center of a black hole and then outside the other end on the white hole, and you probably won't live to tell the tale. Let's just say that. So, like I said, man, they were smart. They knew what they were doing.
But what if there was a way to like create like an artificial tunnel, cause like to like get rid of the pressure theoretically, like a way to basically dive, like like how submarines and like modern day technology. Cause if you go in the ocean, right, the water pressure will kill you. So, but we have technology that can help us survive down there. Yeah. So what if we create something like that, but like a trillion gazillion times more durable to withstand the pressure of a black hole? Could we walk through the black hole and out the other end?
So the thing is that black holes don't have pressure. It's totally different.
What's causing you to get into
gravity?
Gravity is a force that's pushing down on you.
No. So I remember I explained this to you in like one of our first episodes, that gravity technically in college and everything that works right now, Newtonian physics still works for simplistic calculations and everything, but it's actually not correct. It works for large scale, but it doesn't work for really small scale.
So gravity...
It works for everyday things, but it doesn't work for super, super large scale. That's why Einstein made his stuff. So basically gravity
loses all meaning when things get too big.
Yeah, exactly. And too small. So there's like a little fine I guess you could say, boundary in which we can say Newton was a pretty cool guy.
So we're in like the sweet spot, right? Where we
Yeah,
where
like
we have
I can
gravity.
toss a ball to you. I can toss a ball to you and explain that with Newton's laws. But, if I wanted to talk about the sun, probably not.
Okay.
So anyways, I'll explain to you what gravity is in reality. Imagine you have
a big mass and I get stuck to it.
No, that's not it. So imagine you have let's say you have you ever played spike ball?
Isn't that the thing where you have like a mini trampoline on the ground and you play doubles and you like have to hit the ball?
Yeah,
on
it's like the reverse. It's the reverse volleyball game, exactly.
Yeah.
So imagine a setup exactly like that. You have a hula hoop type of thing with some things holding it up, right?
Yeah.
And you have a net on top.
A trampoline, yes.
So anyways, you would put something on that net, and that net, or we could say fabric, because that's what space-time is referred to as a fabric. You would put something on there, and that thing's going to distort. It's going to like come downwards.
Yeah, it's going to go downward, yeah.
Yeah, so that's exactly what gravity is. Now,
but where did it come from?
What? Me. No, dude, I don't know. But the point is, that's only a 3D representation of it, when in reality, or no. Rather, it's a 2D representation because it's only X and Y in like a plane, when gravity is actually 3D, and that gets real shifty.
Is there...
Like try to imagine that plane just with all other directions in 3 dimensions. It's weird. It's so hard to wrap your head around.
So I imagine there is no 3-dimensional model of gravity like there is in the 2-dimensional one. Or if there is, it'd be really messy.
I couldn't explain it to you using the logic I have in my head. Maybe I'm just not a smart enough mathematician.
But
the point is that's how gravity works. So yeah, before you go on, the thing is, like, let's say I dropped a big metal ball in the middle of that net, right?
Yeah.
And then I dropped some marbles in, and let's say I spun them around. You know how you would put those coins in, like in the mall?
Yeah, marbles. Then they spin around.
Yeah,
and
they're
going
to
to
spin around
hole,
exactly,
like a
exactly.
funnel.
Yeah, it's almost like a funnel. So that's basically what gravity is, and so that's how planets orbit.
But eventually, don't they collide into each other?
Well, no, because the thing is, we have also... The reason that's not a perfect example is because Earth's gravity is affecting our system right now.
So everyone has gravity, so it's not like the marbles going down.
Yes, exactly. And there's also a certain point in time when the outward acceleration of the marble, quote unquote, is equal to that same inward pull of the gravitational force. For lack of better words, I use gravitational force, right? So basically, that's why we're able to orbit around our planet. That's why the ISS, the International Space Station, that's why it's been up there and stays up there, and people can go up there like it's a train station, because it just stays there.
So it doesn't orbit around the Earth?
It does.
But they perfectly put it so that it doesn't go out of orbit.
Exactly. That's what orbit is.
These guys are really good at not messing up.
Dude, you have no idea. And the problem is I wouldn't say they're really good at not messing up. I would just say that these guys are really good at not messing up. The crazy thing is also that they mess up so much, and it's so costly when they mess up. Like, do you remember all these videos of when, I don't know, rocket ships would just explode in midair?
I mean, there were 2 famous ones that were with people in it, but...
Yeah.
Yeah, I mean, it costs a lot of money to test this stuff, but, like, I don't consider that a failure. I only consider it a failure if people, lives are lost.
Well, there was a horrific crash. I forget the name. I'm going to find it, though. There was a horrific crash that happened as a result of a really... You'd find this hilarious, actually, knowing myself. It was a really simple coding mistake that involved an incorrect conversion between the metric system and the whatever the U.S. system is called. I don't know the formal name for it.
Yeah,
Like,
one of my
they
programming
forgot to
teachers.
convert from feet to meters in some place, and it screwed the whole thing, and the orientation of the rocket ship got messed up, and one thing led to another, and the thing exploded in midair.
Yeah, that was probably Challenger. Or
Actually, yeah, I'm pretty sure that it was Challenger. It was in the 80s, no? 82, 84?
yeah. My programming teacher said, yeah, that was a simple mistake that caused a giant rocket to blow up.
Yeah, and there were astronauts on that rocket as well, I'm pretty sure. Am I correct? Let me find it.
I mean, that's unfortunate, but it happens, you know. But
I mean, it would be great if it didn't happen. Yeah, it was 1986. They were...
like a teacher was on there and some other stuff.
A teacher was on there.
Yeah, like...
Interesting.
Or
Yeah,
maybe
killing all crew members on board. Man, that's such a shame. I think the even crazier part is that how much effort they put into doing something like that, and then to have it completely messed up by such a stupid mistake from people that are literally putting rocket ships in orbit around our planet.
I mean, that's the beautiful, horrific reality of coding, is that if you mess up one single line of code out of like 15,000, guess what? It doesn't work anymore. And guess what the best part is finding that one line of code out of the 15,000.
To be fair, people who don't code will never understand the true horrors of debugging.
It's true.
Debugging is gonna be a pastime for coders one day.
One day. Today is not that day.
But today is absolutely not the day. It's the one thing that people hate doing. Like, why don't you work? Oh, I don't know. Just look through the couple of thousands of lines. It's like reading a book. This is like the best way to describe it. It's like reading a book and trying to find where the author spelled something wrong. Except it doesn't completely screw the flow of the story either. Like, you would see it and you wouldn't think anything about it. It could be a typo. But in code, the typo doesn't do... It completely messes up everything. Like, it actually matters. So it's just, it's beautiful.
That's a really great example. So, ladies and gentlemen, imagine you buy a book and that book explodes in your face if the person writing the book accidentally made like one grammatical error. Good luck finding it.
Yeah, that's a tough.
God forbid you like get a little sleepy and you glance over the line and you just keep going down, and then you read through the rest of the code and you can't find it, so you have to start all the way back at the beginning. It's great. It's great. I'm not bitter.
He's speaking from life. Experiences right now.
I am a programmer, but the beautiful thing is when you mess up, you won't make that mistake again. You'll make another trillion other mistakes, but not that one.
I mean, this is unfortunately true.
Why did we want to go into space again? Like in the 60s, 50s, 40s? Like who?
Russia, dude.
Russia went to space with the Sputnik. The satellite, the first satellite.
Yeah, but no, you asked why. I'm saying that because of Russia. That's the whole space race, bro.
Well, yeah, but why did they want to do it? They're like, haha,
because
space.
The U.S.
Who wanted it first? Or we both were like, first one to the moon last one to the moon is a rotten egg. Haha, lol, JK.
That's literally it, bro. That's literally it. It's so stupid. I'm telling you, JFK, while he was still alive, he had said we should put a man on the moon. And then I think Russia heard that. Yeah, I think Russia heard that, and they're like, "Oh, let's put a man on the moon before them." Like, no, but they way better publicity.
Yeah, but the Soviets, they put Sputnik, which is just a satellite that does nothing but beep in space.
Okay, but they also did put the first person in space, so that's technically they did.
Did they live?
Yeah.
I thought like they burned up in re-entry.
No.
Oh, okay, maybe that was a different person. What do you mean they put him in space? Like, where did he go?
The first human being that went into space was from a Russian spacecraft.
But, like, where in space?
In orbit, bro.
And how did he get out?
I mean, I'm
Well,
not
they-
a rocket scientist.
they get like
he
a
got out
rope and
because
pull
they
him
were able
down?
to get him out of orbit and crash land into the side of the Earth. I don't. No, I'll find it for you.
Thank you.
Yeah, man. I mean, this is pretty common knowledge, actually. I don't know what rock you're living under. It's cosmonaut
I
Yuri
know.
Gagarin. I don't know how to pronounce that name. That was disgraceful. 1961. He was the first. He was the first person in space.
Cool.
Yeah, man, it's cool. I want to go to space one day.
Wasn't there
You
like a
kidding me?
Red Bull guy who also like longest
Dude,
free
that
fall?
was crazy. That
How
thing
did-
was crazy.
What did they do for him? They just put him
Felix
up there
Baumgartner. Yeah, he went into the stratosphere.
and
which-
fell.
Basically, he just he did a little skydive, some skydive action from the edge of space.
From the edge of the atmosphere.
Yeah. So basically, the atmosphere of our planet is very multi-layered.
Which is why you
Basically-
burn up in entry if you don't do your math homework.
Yeah. So, first off, we have the
Stratosphere.
troposphere. I can't pronounce English words, man. I don't know what's going on to me. Anyways, there are a lot of layers to it, but basically, the troposphere is the first thing. That's where your hard air. Man, I don't know what's going on today. I can't speak. I'm gonna try this again for all our listeners who are listening to me and cringing.
No pressure.
Troposphere. Hot air balloons, airplanes. That's where those things are alive.
Okay.
And stratosphere is the one right above that. The mesosphere is above that. What's this other one called? Thermosphere. That's where the ISS is. And I'm probably not giving a great description of this because I'm also looking at a picture of it. And the point is that our atmosphere is huge. It's got a lot of layers to it.
Where does
And-
oxygen stop existing?
Oxygen
Probably the
exists
thermosphere.
everywhere. It's just in concentration.
So it's smaller, there's less of it.
Yeah, there's way, 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 way less of it starting in the stratosphere, honestly. Or no, dude, even in the troposphere. Like, if you try to go and breathe air regularly at the height that an airplane flies, you would not have a good time.
But there's probably like mechanics in the actual airplane that'll give you air to breathe.
Well,
I
yeah, of
assume.
course. An airplane is a closed cabin, right?
But if
So-
I walked outside of the airplane mid-flight, apart from plummeting to my death, I probably wouldn't be able to breathe very well. Now, would I?
Probably not. If you tried to walk out of a jumbo jet at its peak altitude, you probably would pass out before you could get to a height where the pressure and temperature and oxygen concentration was at livable standards.
It's like the mountains, when you run up the mountain, there's less oxygen up there, so you have to acclimate to it.
Yeah, I mean, technically, so you could go to the top of Mount Everest. Mount Everest is, I think, 28,000 feet.
Yeah, but usually you bring a lot of equipment and oxygen canisters to not die.
Yeah, exactly. So planes, typical flight altitude for planes, commercial planes, is 31,000 feet, 31 to 38,000 feet, right? So that's a full half of, that's another third of Mount Everest higher. So there's not a lot of air to breathe up there. So the point is, this dude also jumped from, I believe it was 120,000 feet.
As you do on a casual Friday morning.
Yeah, 128,100 feet. Wow, this was in 2012 too, man. That's crazy how long ago that was. I remember watching this. I was mesmerized.
Was he an astronaut or just some guy?
Just some guy that Red Bull, he's a stuntman.
He's a stunt man.
No. He's an Austrian daredevil. That's what he is.
Fair enough. Daredevil makes more sense.
I mean, that's what all these Red Bull people are. They just do these crazy stunts, and daredevil activities, and I mean, no, listen, when I watched this video, I was so enthralled by it. I'm telling you, man, I remember watching this and like, dude, all this stuff, all the research and money they pumped into this just for this guy to do one jump is insane.
It was worth it, I think.
Oh, dude, of course it was worth it because he made it out of it alive. It's the biggest free fall jump ever.
It's going to have that record forever.
I wonder who's going to break that record.
What, are they just going to climb like 1 inch higher and then...
Dude, I imagine. So the crazy thing that they did was they got him up there with a hot air balloon. Except this hot air balloon almost looked like a spacecraft, like a space capsule. Like the Soyuz, you know?
Yeah.
It's a space capsule. And they just attached it to a good old hot air balloon and ferried him 128,000 feet into the air.
Yeah.
And so he jumps out and... Dude, but the crazy part about his jump was that when he was on his way down, he started spinning uncontrollably. Because there's no gravity, man.
What do you mean there's no gravity? You're falling. Oh, you mean when he was up there?
Yeah, exactly. So, basically after during his fall, all the air friction was just pummeling him in all, like every direction.
Right.
And so the slightest little bit more in one way could just knock him in a like terrible spinning motion, like where he's just, I don't know, rotating super violently, and like he can be basically tumbling instead of falling towards the earth. And
yeah.
You know, the worst part about that is let's say you lose consciousness, then you're dead.
You're dead. Yeah.
You're dead. It sucks. No other way about it. Man.
They should create like I don't know, like a pinch or a needle device, so when you pass out, just like stab them repeatedly until they wake up for emergency.
Dude, that's so stupid.
Why? That'll wake him up.
Why would you do that?
To wake him up.
Why? How's he gonna wake up from that? If he's unconscious because he passed out, how is he going to wake up just from a little pinch?
Or what? What's something that wakes people up? Isn't there like salts, like special salts that wake you up? Or
bath salts.
Yeah.
Alex, how about you go and try it? Go do some experiments. Go jump from like 120,000 feet. Test out some of your ideas, and then tell me which one worked the best.
Well, someone would have to like monitor it. It wouldn't like if I'm unconscious, I won't press the button, so someone else has to remotely press it.
Oh, I'm not gonna be involved in any ways, shapes, or forms that you try to injure yourself. But I'll definitely be there to shake your hand if you find something, something really cool
if I
at the end.
P, what if you went through a white hole and you like came out of it and it was just like and you're on Earth, but it's a new Earth, and you met yourself and the whole world is exactly the same, but everyone talks backwards. How freaked out would you be? It's like a literal mirror universe.
Is my doppelganger speaking backwards also?
Yeah, this is reverse world. It's white hole world. Would you be able to communicate with yourself? Would you like accept that this could be you?
Are we talking the words pronounced? So let's say I say a word and then I go to the word before it, or am I pronouncing every single letter and in the word backwards? So like how my name is Pete, then would the person say Etep, or would they say, let's say I say the sentence, would I say this? Then would the person in reverse world say, this say I would?
No, they're literally talking in reverse. Like it sounds like they're talking
so
in tongues.
Etep, right?
Yeah, but pronounced like Pete. So Pete backwards would be like Pete would be Teep. Your name would be Teep in reverse world. Cuz Pete Teep.
No.
Yeah.
Are we gonna have a linguistic? No, I don't. We're not doing this.
No,
I'm not getting into a
it's basically
conversation with
Pete.
you.
It's like imagine you talking right now, and then you played it in reverse. That's how they talk. So you take your iPhone, record them, and just play it backwards, and you could understand them.
You're giving me a brain aneurysm.
See, this is real life. This is gonna happen. I'm gonna shove you through a white hole, and you're gonna be in that like chaotic reverse world, and you're just gonna be like, "Oh my God, Alex warned me about this, but I didn't listen to him. I laughed at him."
But dude, it would be pretty sick. I mean, it would be great to see if we can end up on the other side of a white hole. I don't know how that would be even possible. We don't even know if those things exist, to be fair. Actually, one crazy thing. I can't believe we found our way back to this because you're just whatever. But one crazy thing is, have you heard of magnetars, pulsars, quasars before?
I've heard of quasar, not the other two.
Basically, I forget there's a certain distinction between each thing. Oh, no. Okay, so magnetars have extremely big magnetic fields, extremely powerful. Pulsars, I think they're black holes, all these things. These are all black holes that have just shooting jets of matter. So it's so hard to explain because these things are just not normal in general. Space is weird, man. But basically, imagine you have a star or a black hole, whatever. This thing is ejecting matter, which is contrary to the idea that they suck in everything. But because Hawking radiation that I explained before, basically they're just shooting out jets of matter super, super, super fast. And so
this matter is basically them irradiating stuff, right? Like our black holes.
Yeah.
Okay.
But because these black holes are so massive and so huge that it's just like it doesn't even put a dent.
Yeah, they eat more than they puke out, so that's
it's like trying to compare me ripping a hair off my arm and seeing what the difference will be on the scale. It doesn't even do anything.
Yeah. All right.
So yeah, they're shooting out these jets of matter, and that's essentially the similarity between all those three things. Now, a quasar is just the base state, so the base shooting jet out. A pulsar is one that's spinning super, super, super fast. And so if you look at it through a telescope, imagine if you tried to do Morse code using lights, and you would kind of go beep, 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 whatever. You would beep the light at certain intervals, right? And it would be like pulses. So they call these pulsars because these things are spinning so fast that the light finally is hitting the lens almost in a pulse-like fashion.
Okay.
Does that make sense?
Sort of. So what about it?
So no, I'm just explaining what it is.
Okay. Now you've explained
it. And then a
it.
magnetar is just the same thing, but it has a really, really strong magnetic field.
Okay.
Okay. So all those things considered now, those things, some theoretical physicists or some whatever people, smart dudes and gals, they say that these could be our versions of these could be white holes for us. But also I'm really not inclined to believe that because usually they can be just
stuff,
black holes. But the thing is that all these things, they are at the center, there are black holes. So it's just, I don't know, it's just so much physics and so much just BS and theoretical stuff. It makes no sense, but like I said, it makes sense.
Yeah. Pete, I had a crazy idea. Have we ever made an explosion in a vacuum? Like a self-made vacuum?
What do you mean?
Did they ever just toss a grenade into a vacuum and let it explode?
I mean, just toss a grenade into space and let it explode.
No, but space is too big and it already exists. But because space is it's a vacuum, but not a vacuum void of stuff anymore. It has stuff in it.
Okay.
So what if we made our own quote-unquote space that is a vacuum and then created a synthetic explosion? Would we be creating a universe in a box? I got this from the Rick and Morty episode, by the
way. Bro, Rick and Morty is such a good show.
Did you watch that show?
No, I haven't watched it in full because I don't watch shows. I don't have the time for that.
But you watched one of them.
I like the show. I think it's a funny show.
Yeah,
you probably it's a pretty good. It in terms of science fiction and adhering to science in general while also making it fun and stuff. It's actually really accurate.
You watched an episode, I'm sure.
Yeah, I've watched the Meeseeks episode like a million times. I don't know why.
So there's an episode where like his car battery is dead, and he goes with Morty to the battery, and he explains this is a this is a microverse battery, which basically is the way he describes it is he created a like temporal field in a vacuum and just waited for life to exist. And then he went into the battery and made them create electricity for his car. So that's his
Oh
car
my
battery.
God. You see, dude, that's what I'm saying, man. that like it totally makes sense.
But like,
And
could we
what
do
if
that?
that's exactly what's happening to us right now?
Yeah, what if we're just the universe in the box and
I mean, technically yes, but also we have to think what are the contents of this grenade, because you would have to make sure that there's really heavy. I think the important thing is if you're going to explode something, you need to make sure that there are very heavy elements in there so that when all the particles kind of explode, they can gravitate towards each other and form the necessary particles.
well, that's not how the universe like stars, for example, they usually start with like helium or hydrogen, and then they just like bash into each other until they eventually form into like helium, and just they repeat that over and over again because their protons just collide into each other and
Yeah,
create
but
new
Alex,
stuff.
a universe is not made of only stars, my friend.
Yeah, but it started that way with star gas or whatever that special gas is in space.
Star gas.
I don't know what that special space wind is, but that's what everything apparently is made out of in one way or another.
I have no idea what you're talking about.
There's like the floating space gas thing. Not gas, it's just like floating clouds of stuff in space that just eventually clutter together and form into a star, a planet, a comet, etc., etc.
Dude, you're just living on a totally different plane of existence right
Pete,
now. I have no idea what you're
I'm
talking
gonna look
about.
into this and I'm gonna reveal it next week because I don't think I'm crazy. I'm 90% sure I'm not crazy, but we'll find out next episode. Please watch listen to next episode, everyone.
Okay, so yeah, I think that would definitely happen. Like I said, you need to have, I don't know. This is like ironic, but you would want to use a heavy element like uranium or plutonium, and then when you explode that thing, like hopefully you can explode it to the point that all the atoms are ripped to shreds, and that way you can form lots of hydrogen, some oxygen, and then all the carbon, because life needs carbon to exist, right?
Yeah, but then eventually over time in that box, things will take its own form.
Yeah, but based on what we know right now, I mean, yeah, obviously we don't know. And we'd have to also measure this over billions of years. I don't know if you have enough time to do that.
Is there a way to accelerate time?
Yes.
So
have you heard of special relativity?
No, Pete. I have not heard.
Well, actually, no. This would be... it's not accelerating time. It depends on the perspective. Okay, so I'm going to school you right now. Bro, Einstein is just the crux of this episode. But yeah, he was a cool dude also. He's like, okay, kind of smart. Einstein he postulated the theory of special relativity, which essentially means, have you ever heard the twin paradox?
No.
Okay, so the twin paradox explains special relativity. Let's say it's me and you. We're twins right now for thought experiment purposes. We're twins. Right. I stay on Earth, you take a rocket ship, and you fly at the speed of light for 20 years.
Okay.
Now, you fly 10 years out, 10 years back. I've aged 20 years, so I'm 40 years old now, and let's say for experiment's sake, you're 20 years old at the start as well. But you've been flying at the speed of light. Because of you flying so fast, you come back and you're still 20 years old. And that's what special relativity is. So time moves slower for people that have faster speed.
If I was traveling at the speed of light for 10 years forward, 10 years backward, and you stayed on Earth, within a year... You mean 20 Earth years, right? Not 20
Yeah,
20
years. Earth years. I've aged 20 years, and you've done the same thing. You've been flying in space at the speed of light for 20 Earth years, but
20 Earth years. Okay, yeah, got it.
when you
Not
come
20
back, you're
light
still
years.
20 years old, but I'm 40.
Yeah.
But yet we were born at the same time. So, like, that's kind of freaky, right? That's special relativity.
Yeah, that, yes, technically, but that, the thing is, I have to be able to travel at that speed, which I can't. So I won't. But yeah, no, I get the concept. It's like, if I
Yeah.
could, then yeah, you would be older than I would, even though we're the
Yeah.
same.
So your question was, how do you speed up time? And this is the greatest irony behind this. And the thing is, this law is completely true. The greatest irony is, to speed up time, you need to go as slow as possible. But we all know, based on school, that the slower it goes and the more boring it is, the longer it feels like it is.
So I have to slow down time in the temporal field in the box universe to make it go faster.
No. You need to slow your speed down.
I have to slow my speed down so that
Yes,
their speed
dude.
speeds up.
Were you not listening to me?
Yeah, so no, that's stupid then, because that's just me. That's not it going faster. It's me. That's me going slower. So yeah, I guess that's special relativity for you, because it's relative. Technically it's moving faster than I am, but it's not doing it because it is faster. It's doing it because I'm slower.
Yeah.
That's stupid. That's
Well,
bad idea,
relative.
Pete. Bad
Stupid
idea,
is
Pete.
stupid is also relative, Alex.
Everything is relative. All right. If we did have a universe in a box. Okay, so we talked about teleportation. Either we're going to end this or we're going to keep talking. Is it possible to shrink people?
I don't know why you've made me the authority on this. I guess I'm more experienced in this stuff anyway, but I feel as though
Probably not, because
that's definitely a possibility.
That's probably not, actually. It's more realistic to grow than to shrink, because in programming, for example, when you try to compress things to make it smaller, you have to take stuff out, and usually you take a certain amount out to make it look similar to what it was originally, but it's still less than itself, and it's very difficult to put it back together from shrinking it back to the way it was. But making it bigger is actually really easy, because all you do is you take one particle, or for programming 1 pixel, and you just make it bigger by instead of a 1 by 1 pixel, you turn it to 2 by 2, and you just do that for every pixel. Whereas for shrinking, it would be more, for compressing, it would be more like you take every other pixel out. And as you can imagine, once you have the shrink product, it's very difficult to put it back together because you took it away.
True.
So probably shrinking won't work. But wait, then my idea still has some merit to it. What if we take the universe in a box and made it bigger? What if the multiverse is just a universe in a universe?
What?
What if the multiverse is just you're in a universe within another universe?
No, I heard you. I said what because I'm just trying to wrap my head around that.
No, because if we create a universe in a box, that universe is in our universe, but it's its own universe. It's doing its own thing, just in a box that we made. So
I mean, realistically, yeah. Like I said, imagine that our universe. Because let's say we create that universe, then we are simulating a universe, correct?
Yeah.
So essentially, then our simulators have their own universe, which in exactly proves your point that the multiverse would be just concentric universes. That's so freaky. Oh my god. That's freaky. Yeah, that's really, really freaky.
What if the only way to escape our universe is to get really big and just break the box? What if that's the meaning of life, or the secret to the universe is just shattering the boundaries of our so-called box and to transcend into the new universe?
I'm sorry. I just hit the mic with my head because I'm just taken aback and then I don't even know what to say. No, I do know what to say. Stay positive, Alex, and I promise you that you'll absolutely achieve your wildest hopes and dreams of making it into a new universe.
Thank you, Pete. That's all a boy could ever ask for. Ladies and gentlemen, I hope you enjoyed the science fiction sleepy time episode. Tune in next week where I discover what space cloud, space wind, space gas is. Stay positive, guys.
Peace.